Okay, in this video episode, I'm going to show you how to know whether you have a horizontal or a vertical dilation. So first of all, we have a parent function, y equals log x, and it's going to be transformed to y equals 4 log x. But before we do that, let me just read the question in detail. The question says, describe if the constant shows a horizontal or vertical dilation, and then we're going to state the scale factor. In addition, I'm also going to give you the bonus of a visual representation so we can see what it's actually doing, this dilation factor, up here on the number plane. So let's begin off with trying to determine whether it's vertical or horizontal dilation. Well, we got a y equals 4 log x. Now, is it in this format where y equals k function x, and that's a vertical dilation, where k is the vertical dilation factor, or is it y equals function ax, where a is related to the horizontal scale factor, and that being a horizontal dilation? So is it this one or is it this one? Well, it actually looks more like this one. Let me just put this in the right format and you'll be able to see that. So this is in the form of y is equal to k log x. K log x. It's in this format where k is the vertical dilation factor. And in this instant, k is equal to 4. And what does that mean vertically? It means that it's 4 times as tall as the original parent function, which is y equals log x. And if we look here, I have that already drawn for us. We have y equals log x right there. So whatever we draw now, when we apply k equals 4, because that's a vertical dilation factor, it's going to be 4 times taller from the x-axis to the new curve, y equals 4 log x. So let me just draw this now, because we know it's going to be well, because k is greater than 1, it means it's going to be vertically. So it's going to be 4 times taller at a factor of 4 away from the x-axis and up towards the y-axis. So let me just mark that out. So we've got the existing sketch right here. So I'm going to pick points along the x-axis and the curve y equals log x and count 4 times up all the intervals. So let's begin the first one. At 1, 0, we can't count because both of them will go through 0, because if I go multiply 0 by 4, it's still 0. So let me just go over here where we got 2. We got that much space. It's just under 0.5. It's about 0.4 or 0.3. So if I go up 4 times, that's 1, 2, 3, 4. It's going to look like it's going to go right there. If I take this point here, doesn't matter how high it is, I'm just going to measure it with my finger. That's 1, 2, 3, 4. It's going to go to about there. This one's about that much. 1, 2, 3, 4. It's about there. So it looks like it's going to go like this. So there's our new function, and it's actually 4 times taller than the existing parent function, y equals log x. I'll just write it in. Y equals 4 times log x. There it is. As you can see, it's taller, closer to the y-axis, further away from the x-axis. Again, it's a vertical dilation. It is stretched because k is greater than 1, and k is equal to 4.